This is MakeCode, and this is Grandma. And I had so many programs open, I forgot I had both my streaming program and the Mixer channel open, and that created a feedback which made so much noise I had to mute my computer, and I'm sure you don't want to know all that. So what we're going to do today is we're going to play with buttons and lines. And to start with, what I want to do is to demo a little program. Let's see, this one. I created this program a while back and published about it on my blog. It was called Kaleidoscope. So my blog is at MakeCode.com, and scrolling over in this area, you'll see a program called Kaleidoscope. And this goes into lots of gory detail about how Kaleidoscope works and how I discovered it. I'm sure this has been discovered by other people, but basically the wonderful thing is that when you create a line in MakeCode, of course the line has to be drawn in pixels. So therefore the lines, the rounding caused in calculating the lines causes these interesting overlapping patterns to occur. And that's what we have. So I want to close all and show you. This program has lots of user features to design the things that you see, but so now that's Kaleidoscope. What it's doing now is generating a palette of random colors and then adding those colors to the design pattern one at a time to create very interesting things. And the thing that this program did not have was a way for the user to specify the patterns. So when I created the program we're going to work with today, I decided I would make a program that was simpler because it wouldn't have very complex user inputs, but would allow the user to create his own patterns or her own patterns by specifying the colors to be used. Okay, before we get too far gone, I want to copy up all these URLs for the program. Oh, close. We don't want to do that. Okay, that being done, get rid of that. Okay. Now what we want to do is to show the final program, lines and buttons and lines, and then we're going to go back and create the program step by step. This is buttons and lines. You select a particular color by selecting a button. Once you have it selected, I call these buttons because if I had a mouse, well actually if I had a touch screen here I could just touch it, but I'm having to actually select one using the B button. And I can go to any combination of colors I want and any number of colors I want, and there's a beautiful pattern. Now, what if I didn't like that last color I added? I can go back here and unselect it. Okay, cool. Well, at least I think it's cool. Now, notice what this is doing, because we're just about to code it, and we need to think about what this program is doing. It's using the A button to switch back and forth between the pattern and the buttons. And when you go back to the color selection buttons, they are in the same exact state as they were when you went to this. The sprite, this is a big sprite on which on which the pattern is drawn. The other thing that's being done is these are used to scroll around the various patterns and to select them. And the B button is then used to select one or unselect one. Okay, and that's what the program does. So now we're going to go over to this which is the stub of the program. So we are now going to make this program sort of from scratch. So you always have an on start, and obviously we're going to have to create the buttons, and we're going to create a great big sprite on which to draw the beautiful pattern. And these two screens, so to speak, are going to be mutually exclusive. And so we have a function that will create the buttons. We have a function that will make these great big screens, and we have some function to cover the buttons and to uncover the buttons. So this gives you a hint that we're not going to make the buttons go away. I actually experimented with that, and that was way more trouble than it was worth. So what I do is actually use the Z, or the up and down, the order of sprites, and by bringing the sprite, the big sprite, to the fore, that covers up the buttons, and then I can put it under the buttons by changing its Z again. And I'll show you that in a minute. Now the idea is that when the A button was pressed, if some condition were met here, then we would uncover the buttons. That's when you want to go back to select more colors. And then if it's this condition, you want to cover the buttons. And obviously here you're going to draw the beautiful pattern. Okay, let us start by creating the buttons, which is kind of the most interesting part of this. And I got all excited recently when I discovered the data extension. And we're going to just add that right now. Sprite data extension. Okay. Please open. Had a little trouble with this. Okay, let's try that again. Patient, patient, patient. This is not my network, believe it or not. This is something going on with Arcade that I'm not able to get to the extensions. And actually, it's not just that. I can't get back to the... Okay, I'm going to go back to the home screen. Okay, this is what we're working on. And I'm wanting to add an extension. Yay! And that's what I have to do. By the way, I rebooted. That is, I closed the browser, I opened it again, and I opened my program again, and then I can find the extensions. So here, the one I used and am so excited about is Sprite Data Extension. There it is, Sprite Data. Cool. Now, when you have Sprite Data installed, and I want to show you that, well, if I show you, it's going to mess up all my buttons. But if you go into JavaScript, you can see that the extension is installed, and in fact, you can read the code for the extension, and that's how to learn to write extensions. But for now, I'm just going to show you what this extension does. To the Sprite dialog, it adds these very interesting things right here. And you can store data associated with a sprite, and you give that data any name you want to. And you can store any number of, until you run out of memory, data items. And they can be booleans, they can be numbers, they can be pretty much anything you want them to be. So, in creating the buttons, the first thing we need to do is make an array of sprites. We're going to go down to arrays. And I think we will very, very cleverly call this let's see, what should we call it? Buttons, buttons. In my own coding, I sometimes call these arrays a list or an array, but I think I've decided a better method is to just be sure it's plural. So rather than say button list, I just say buttons. So therefore it's obvious there's more than one buttons. So then I want this to be an array of sprites of kind. And you know, there's absolutely no need to change this player. It can be called player if that's what you want it to be called, but it offends me. I want either to say none because I'm actually not using it in the program, or I want to call it what it is in case for some reason I wanted to use this. And so when I first started programming this program, I thought, well, maybe I would want to use it, so I called it button. And now I wish I'd called it button, not buttons, but we'll just ignore that. So now each button is going to have a different color. So I want to loop through this and create a button for each color. So that calls for a loop with an index, and it's going to go from 0 to 15 because there are 15 colors and one non-color, which is the 0th color, the see-through color, in MakeCode Arcade. So this would be 16 buttons, which is what the screen shows. So now I'm going to make a variable called a button. So this is just one button, and I'm going to set that button to a sprite. I'm going to create the image. And each one of them are going to be 40 by 30. Now, who knows why they're 40 by 30? Yay! A whole bunch of people held up their hands. It's 40 by 30 because I want 4 on each row and 4 on each column. And the screen size of the arcade is 160 wide by 120 tall. So I want the buttons to cover the entire screen. And of course, this is a button, and I want it to be the same type as the array, although I think maybe it doesn't have to be. Now, is there really something wrong with that? Type sprite is not assignable to a type number. See, it thinks a button is a number, but it's not. It's now a sprite. So, why doesn't it know that? Well, I'm going to show you something. Sometimes, when you close and open again, see? Oops! Okay, does anyone know what's wrong with this? Kind sprite. This is a sprite. Okay, I'm going to do this another way. Set. Didn't I do this to start with? Set a button. I'm absolutely positive that this should be okay. And if you see for some reason it shouldn't, please let me know. I guess one thing we could, let's try. Okay, I'm going to just keep going, and maybe I'll figure out in the background of my mind what's going on here and fix it later. So I want to have a variable which is associated with that sprite, which is, hi, Killer B610. Do you know what's wrong with my sprite? If not, I will keep going. So I want this to be a Boolean. So right there, I want my A button, which, see, it thinks it's still wrong. Okay, we're going to do this one more time. I'm going to set my sprite to that. See, there's no error. Okay, so I'm going to move this to there. You know what? I think maybe that had to do with the, oh, let's just try this. Okay, we'll just keep on calling this my sprite. And later maybe I can trick it into doing what, see there? It's all good now. So, get rid of that. And I want this data to be named selected. So I'm going to have a different sprite for each button, each color, and if they are selected, I'm going to set this Boolean variable to false. And so I initialize it to false. And then I want to have another one, which I will call row. Whoops, I want it to be a number. So let's get rid of that. Go back to sprites. There's a number. And I want this to be called row. And this is the row in which the button is located. Well, how do I figure that out? Well, I calculate it from the index. And the way to do that is to use this way. The row is the floor, and floor is down here with round. And floor means if it's like 7.3, it's 7. In other words, it's the number, the whole number under the number that was calculated. That's the floor. And we want it to be the floor of the index minus 4. So we get us the math here, negative, and it will be, okay, oh, there, index, come on, come on, come on, come on. See, this is not a feature I like. So I sometimes do this. Sometimes it works better if I take it out, take it apart. Oops, there. So I've got index minus index divided by. Sorry, Grandma's eyes aren't really good, so I did that wrong. It's going to be divided by 4. And you can try that. Try a couple of examples. If the index was 3, well, this number would be in row 0, I hope. Okay, the next sprite you can probably guess is a column, and it's going to be the remainder of index, oops, sorry, index divided by 4. Okay, we will test this really, really soon. I don't understand. Okay, was that this, I don't know, sorry, I don't know what you didn't understand. Is it how we calculated this? let's go back and look at that during debugging, and maybe it will become more clear because we can actually see then what's going on. So now these buttons don't have a color yet, or these sprites do not have a color. So we're going to fill the sprite image with index. That's the color. See this, we're going to go through one time for each color, and so the index is the color. Now, where do we want to position this button? Well, how about setting the top to what? It's a little bit complicated. The top is going to be 30 times a button's row. So we just go up here and to sprite data, and we get the a button row. And what is going to be the column? Whoops, I should have said set there, so that's not good. Set my sprite top to this. And then we're going to set my sprite left side to 40 times the column. Whoops, go back. Okay. Then we're going to set the Z depth, and this is the up and down. You know, it determines which sprite is on top of another sprite. And this is the default, but we're going to set it to 0. And the reason I put, although it defaults to 0, the reason I put it here is I just want to, because I'm using Z depth, I just want it to be completely clear in my code that that's what's going on. Now I want to add that sprite that I created, which is a button, to the end of my buttons array. So this should be buttons, and I'm going to add that sprite to the end. Yay. Now, how about we just run this code? There they are! Yay! Now, I know it may be a little, this math that I use to calculate the row and the column and the position. The only way to understand it, or to even figure out how to do it, draw yourself a little picture, do some little arithmetic until you figure out how it works. And then you test it, just like I did here. Okay. Now, how would you hide these things? We're going to make ourselves some big sprites, which is what we're going to draw on. So, I'm going to have a big sprite. And this is going to be a new variable called the draw on sprite. And this is the sprite on which the lines are drawn to create that beautiful pattern. And it's going to be an image oh, please. Spend half my life trying to get these things to lock in. So we're going to create an image. See, if you take them out of where they are, it somehow works better. We're going to create an image that's the same size as the screen. And the screen is 160 pixels wide and 120 pixels high. And then we're going to fill it I'm going to fill this with, go up here and get myself a the sprite image, and I want this to be the drawn sprite. Okay, now a very interesting thing. If you just have this pattern, a very interesting thing happens. I think I'll just demo it. Oops, I want to fill this with black. Thank you. So I want to go ahead and fix this. I'll see. Well, I call uncover buttons, cover buttons. No, I have too much to do, so we'll have to demo that later. It turns out that I actually need two of these sprites to put on top of each other. And the way I do this, and it's a very weird reason why, and it has to do with how the lines are drawn, but I have not been able to recreate it in a simpler program, which is depressing. So this is a new variable. This is like the underskirt, or it's the under sprite, and I call it behind drawn sprite. And this then should be behind drawn sprite. So it's otherwise just the same at this point. Now, these two things are how you cover and uncover the buttons. So to cover the buttons, I just set the Z values. So I set the Z value of the drawn sprite to 1, which is above the buttons, because remember the buttons were 0. And I set the Z value of the under sprite to 2. Well, that's got it covered. You know, I did that backwards. So I want the drawn stripe to be on the top because we want to see the pattern. No, sorry. I want it to be, these to be both over the buttons. So 1 and 2 is higher than the buttons. I can get myself mixed up on this if I'm not careful. Now, to get better. To uncover the buttons, I'm going to set the Z values. To -2 and -1. And see, those are under the buttons because they have a lower Z value than do the buttons. Okay, so if I had a way to test this, which I think I can make, so it says if this is true, which it is, it will uncover the buttons. Well, let's just set it to false to test, and it should cover the buttons. So let's just see if it does that. I don't see any buttons. Hello? Oh, it covered it when we started. So I have to do something about the beginning, right? So when I create the buttons, I want to call uncover the buttons. So call it function uncover the buttons right after they are created. Oops, that's no fun. Uncover the buttons. Oh, I hadn't made the screens. See, you have to make the screen sprites before that will work. That's why the error, I thought. We did not make the buttons. Let's see if that makes the buttons. We did not make the buttons. Let's try this. This is typical coding. There they are. Okay, now we got the buttons. Hi, Rasfer. I'm sorry if I mispronounced that. Welcome. Now, let's see if... So this is not uncovering the buttons. So we made these. Okay. And we tried to uncover them, and that didn't work. So let's go see what was wrong with that. When we uncover the buttons, we set these Z values to, oh, look at that. We set 1 to 0, which meant it was over the buttons. It was right the same as the buttons, which makes it over. Okay, let's try it again. There are the buttons, and I'm going to punch A, and now they're covered. And if I punch A again, if it were working like it eventually will, they will be uncovered. So that's how you cover and uncover the buttons. Okay, so now we have buttons, we have a screen on which to draw, and we only need a little more code to make this thing actually more or less work. We need a thing called status. And what we need is a variable. This variable is going to enable us to go back and forth between the two screens, which are actually between the buttons and the screen on which the pattern is drawn. And so it's a Boolean variable, and I'm going to make it B. I usually call my Booleans B, so I know instantly that's what they are. State is... So if this thing is true, that means that the buttons are showing. Now, I want to set that variable in the very beginning to true. then when we go over here to the A code, the A button code, that is the variable that we test right here. State is buttons. Oops. A variable. Okay, got it. So if it's true, we go to uncover the buttons, which means they show, and if it's false, we're going to cover up the buttons. Okay, we have about 20 minutes left, so I am going to jump over to the finished program, which is this, to show you the rest of how it works. Okay. Notice I've added just a few things here, but it's pretty much the way we had it. Right here, oops. To start, we had to add this because you want some button to be selected at the time you start. So notice when it runs, that button is selected, which is 2, 2, 0, 1, 2, 0, 1, 2. So that's 2, 2. I could make it 2, 3 if I wanted to. There it is. So that's a good way for testing all the rows and columns to see that they work like you want them to. Okay, now let's see what we need to do next. I'll just show you this. When the B button is pressed, then what we do is we set the selected piece of data that's with the buttons to selected. An active button is the button that is currently selected, and that's changed, guess how? Up here in the arrow keys, which is when you move around the arrows to select a different color, we call this routine calls if buttons make active. So that's saying if it's in the button state, then make this button with this row and column active. And this looks a little complicated, but it's really not. Basically, if you're moving left and right, you're only moving the X, the column, and if you're moving up and down, you're only moving the row. And you're calling this routine, so make button active, and what that does is go over here to make the button active. This is how that works. That's the row and column we want to be active, and so if we're in this button state, we calculate row to be this remainder of the absolute divided by 4. Why are we using the absolute? Well, it's because the buttons, in using the arrow buttons on the controller, I didn't do any checks to see if it was out of bounds. But what this does, this code causes it to always be in bounds, because since it's modulo 4, it will never be bigger than 4, and because it's absolute, it will never be negative. So that enables this functionality. So I can move. Well, that's not working like I wanted it. Notice this one is cycling. Now it's working. See, that's doing something a little funny. So I need to work. Now see, it worked that time. So what is causing this to be intermittent? Well, that's what's known as a bug. And programmers, coders, we absolutely love to find a bug in our program, because that means we can fix it and it will not be in the release program. But right now, we'll just note it. We will not fix it. I will fix it later. And next thing we want to do see this? We make a button active, and we have a button variable we just call active button. So this variable active button, you notice it was used in some other code. And we want to set the state borders. What in the heck does that mean? Well, notice that when this is selected, it's yellow when it's not selected, I'm sorry. It's yellow when it's active. Now, if we select it, selecting it, it turned red. That means it's actually selected. So that color will be used. And if there's no, if it's neither active nor selected, the border is black. So this code right here does that. Set state borders. So it goes through the whole list of buttons, and it checks if this button has a data called selected is true. Then, and by the way, I couldn't get this to work by itself, which I think it should have. So I had to say equal true. Then I set the border color routine called set border of that sprite to 2. Well, that's red. And this one is yellow. If it's active but it wasn't selected, then it's yellow, which is 5. And then otherwise, we just make it black. Well, why did we need to even bother with this? Well, because it may have been selected before, but it wouldn't be now because you use the cursor to move it. Okay. Now, what else do we need to do here? The one other thing that's a little bit tricky is this code right here, which is, makes the whole thing work. This is like the heart of the program. So remember, this variable it flips every time you hit the A button. So the A button's hit, you flip it. Flip it means you just take the knot of it. So if it was positive before, it's negative now. We fill the drawn sprite with black because it's kind of like erasing the pattern that was there before. And if the state is buttons, you call uncover buttons. That's all you have to do. But if it's negative, if this is false, then we want to do something else. The first thing we do is we have to create something to pass to the pattern. We have to pass the selected buttons to the pattern. Well, I want to pass it as a parameter. So I'm going to call this routine that creates a string, and I'll just show you that quickly. The only purpose of this routine is to make a string with the color number of all these sprites that are selected. And I make this by separating them with a up and down thingy. And so that means you have a string of numbers separated by an up and down. That will allow me to split it into the array that is actually the colors. So we just call that, and if the length of that is greater than 0, meaning it has some colors to pass, we cover the buttons. So we have that wonderful black drawing surface, and then we call do line pattern. And we pass this draw on sprite, which is the sprite, the big black sprite you wanted to draw on, and we pass this string called CS. And then you have this wonderful little routine here, which this is described thoroughly in the blog post about Kaleidoscope, so I'm not going to spend much time on it here. What this does is there's a sprite in the middle. It draws a bunch of lines. So it starts by having in the middle, I call that center X and center Y, CX and CY. Oh, first we get the color list, and by splitting this string in, using the up and down thingy. So now we have an array of colors that we're going to use. And we want to use those colors over and over again, going around the list of colors. So we have a counter here that counts which color we are on. And this code right here starts at the top and varies X. So it starts at the center and draws a line to the corner, then it draws a line to the point specifically to the right of that, then the next one and the next one and the next one until you draw all the lines towards the top. Then you draw all the lines that go down, and then you draw the lines whose endpoints go on the bottom, and then the lines whose endpoints are on the left. Now, it's kind of fun. You can understand this by just taking some code out like that, and this should only draw the top one. So let's pick that color and that color. See, it drew from the center to each of the top pixels, and then it will go down here, then here, and then back up until it creates the whole pattern. That's what you do when debugging. And believe me, it's a little tedious getting all these things correct, but patience pays off. Okay, I think that's it, unless somebody has some questions. Now would be the time. Okay. Oh, I see one thing I didn't tell you, so I'll just show you that right quick. This routine that says set state borders, it calls a routine that does that, and that routine uses this wonderful function called draw rectangle. So that draws the outer edge of the sprite and the next to the outer edge of the sprite. So there's a 2-pixel border around the entire sprite, and it does it using the specified color. And that's all there is to it. So I hope you can download this from MakeCode. No, I'm sorry. You download this from GitHub, and I gave you the URL earlier. So please enjoy. Thank you. This is Grandma out, and please join me next week on Wednesday at 2 o'clock Central, noon Pacific on MakeCode channel. Bye.